So this green terms in terms of pz is like this. This green term also in terms of pz is like this. So can you understand this 1 into 2, this whole step? Is it okay?
Okay, okay.
All right. So I think the direction, maybe my explanation is not so good, but the direction is clear. Because all the ways I managed to follow the books and also the standard derivation of wave equation. I just play with the wave equation. I do nothing new. Okay.
Okay.
So this is our main results, and after this, just play around with this. So
Okay.
how to play around? You see, I try this term. Let me see the negative. Okay, here got no that. Okay, this is exactly the same. Copy paste, and this term carry this. This term without epsilon naught. So here I try to multiply with epsilon naught and divided by epsilon naught to this term. So I copy paste and I change just this term by doing this and this. Just understand. And the del square, because we consider only one dimension, the paper consider only one dimension. It's not 3 dimension as our playing with perturbation. Our perturbation, we play with 3 dimension, but in this article, he play only with 1 dimension. The dimension of space is z. So the del square here become d squared over dz squared. In other meanings, it is d over dz followed by d over dz. Okay, so del square here replaced by d squared over dz squared. Okay, so this term operates with this, you have this term, and this term operate with this, you have this term. So here I do not work out this one. I write down d square bracket PPP. Yeah? Okay, and then this term and this term are the same. We can factor. No need to factor. This omega square, very noisy here. Omega square mu naught epsilon naught is equals to omega square over c square. Because mu naught epsilon naught is 1 over c square. All right. So I just use the definition. This equals to this. So this equals to this. So this is nothing new. If you go through electricity and magnetism, you know the definition. Mu naught epsilon naught is 1 over c square. Okay, so this term remain the same, and this term remain the same. So here my approach here is just to simplify this and this del. Right, I write term by terms. Okay, and then after this, I simplify this term. So I expand this term. Okay, the derivative of P star PP, okay, is d over dz PPP. So because d squared over dz squared are the same, and this are the same. So first of all, I write 1 d over dz outside. So we have d over dz operate on PPP. Okay, so the results of this operation is this. So this one I leave it to you. You work it out. Is it okay?
Sure, doctor.
Okay, yeah. So the d over dz of this 3 term is this. So this is the first level of derivative. The second level is not yet. Okay. So and the other terms I do not change because the other terms are just single p. It's just one p. No problem. This one you don't have d over dz should be okay. Here also you have only one p. So this term, until the second step doesn't change, these two terms also do not change. Okay, so now this term change to become 4 terms. Why we have 4 terms? Because we operate this d over dz on this and also on this. On this you have some terms. On this you have some terms also. Simplify. Okay, you have these 4 terms. Okay, right? So this term, until this term, I leave it to you. I think to derive, you have no problem, right? See whether you can get the same results or not.
Okay, doctor.
Okay, and then after this, do I further simplify? Yes, after this I further simplify because I found that this yellow term and this yellow term should be the same. The difference is the sequence of P naught, P star and is the difference of the dP over dz and the dP star over dz. The dP dz comes first, but this term is the dP d star comes first. But they are the same. So in the first order, in the one dimension, it should not be very different. So I assume that they are the same. So this term and this term, we collect together, become 4. So the 2 become 4. So these are the only change. Okay, for the last semester, I said there are 2 possible of trial, but I always start with the first, the simple trial. The simple trial is the simplest approximation. So we know that from the beginning here, we assume that P is the product of function of Z and function of time. Okay, so and for the function of Z, according to the paper, okay, that's why I always go back to paper for the consideration. I adopt the results. Okay, the function of Z, you look at this is the articles that we use. The article consider the function of Z because all the time factor exponent already cancelled in the equation cancelled already. We left only the PZ. So the author assumed that the function of Z is some function of Z, gamma Z here, multiplied with another function of Z. Okay, and my consideration last sem is whether we should consider this gamma and this phi as complex function or not. But I always try with the simplest. I said that they should not be complex. So I use the gamma real and phi z also real. So I try this, it is working. Okay, remember our results, combining the results from the articles and the wave equation give us this. So this term, this equation, we have P and also we have P star. So we just follow the assumption of the article. The P equals to gamma Z exponent I phi plus kz. So if we consider the gamma and the phi is real, the P of course will looks like this. But the P star looks simpler because we need just to change the sign in front of I. The sign in front of I here is positive. If we take the conjugate, then the sign in front becomes negative. This is the only change. Okay, and you can see that the gamma Z, why I said become gamma, because up to here, I don't want my writing, my typing become complicated. I just drop the functional argument. So sometimes you can do